So we're going to start a new unit right now. Hope the test today went okay. We're going to start a quadratic unit that will actually take us through the beginning of the new year. You should have picked up a new calendar today and a worksheet that you will need to fill in these notes. So, right now I want to remind you that quadratic means any function that has a squared term in it. Okay, nothing higher than a squared, but a squared term in it. We know that the parent function is y equals x squared. And we're going to be looking at vertex form. There are three forms, but the form we're going to be looking at is y equals a times x minus h squared plus k. And this should look familiar to you guys. That x is kind of terrible because we've been dealing with a and c and d, or in some cases, we've already started calling it h and k. So, the a still is a vertical expansion or compression. It also reflects over the x-axis. The h shifts us left and right, and the k shifts us up and down. So that's not going to change. The next thing I want to remind you of is what a quadratic looks like. Okay, so a quadratic is a graph called a parabola. Very freehand here. It could either open up or it could open down. They either cross the x-axis twice, they don't cross them, or I could even draw one where it crosses once. Right there, crosses there, doesn't cross at all. They all eventually will hit the y-axis. You can see this one's going to hit it right there. If this continues down and out, it's going to hit somewhere down here, and this one looks like it's going to hit way down here somewhere, but it will always hit the y-axis. And we need to remember that an x-intercept always has one thing in common. The y is always 0. The y-intercept, the x is always 0. And we will find these other pieces of the coordinate in different ways. So we're just going to look at some terms for now about graphing in vertex form. So one of the reasons I like doing videos is because I get to show you new experiences for me. I went to Atlanta this past weekend to visit my daughter that goes to Emory University, yes, where Ebola patients have been, and check this out.
Red velvet. Where's a normal red velvet? Red.
I drove from Bravo to had one.
You have reached the maximum. I think it's just because it's this.
Okay.
All right, so we'll just get 4.
We're gonna do 4 red velvets.
Shit. Okay. 2.
Okay, add another flavor.
Okay, let's do chocolate marshmallow.
Okay.
Got it. Check it now.
Stay tuned to see what happens at the end of the video. So before we start this, let's make sure we do a parent table of the parent function. Okay, remember for parents we always use -2, -1, 0, 1, and 2. And if I plug that into the parent function, y equals -2 squared, this is going to be 4. Y equals -1 squared, this is going to be 1. 0 squared, 1 squared, 2 squared. Then I'm going to plot those points on, and this is my parent function. Okay, and what I want you to see is this shift from my vertex to my first point. So right here, I go from my vertex up and over 1. okay, on my parent function. And then I go up and over 4. Sorry, up 1 over 1, up 4 over 2. Okay, that is going to be my vertical stretch, and we're going to talk about that in a minute. What is the vertex of this guy right here? Well, that would be -2, -3. And what I'm doing is I'm just following this A, B, C, D, E, F. Okay, write the equation for the axis of symmetry. So the axis of symmetry is the vertical line that goes right through the vertex. The axis of symmetry is always going to be x equals -2. It's always going to be x equals the x. Write the max or min value. Okay, this guy right here is the bottom of my hill versus a quadratic that would look like this, where this would be the top of my hill. This would be a minimum, this would be a maximum. Okay, so you should have paused in your notes and you should have written this down. This is a minimum, this is a maximum. The minimum value is whatever the y-coordinate is at this point. So this y-coordinate is -3. So the minimum value is -3. Vertical expansion or compression from the parent. So this is where I was talking about the up 1 over 1, up 4 over 2. We're going to look at this one, up 1 over 1, up 4 over 2. And that both gets me the points on my transformation, the same stretch or compression. So there is no stretch or compression because those movements are the same as the parent. Horizontal shift left or right. Well, if I started at the origin from the parent, I shifted left 2. So my vertex went left 2. So I'm just going to write, I went left 2. And I really wish it had an E sub A here, because I would like to make that, is there any vertical shift? So we're just going to add something up here in our directions. Is there a vertical shift? Because I think we can very clearly see that this guy shifts down 1, 2, 3. So we're going to say that there was a shift down of 3. Okay, the domain. Domain is left to right. Say that again, domain is left to right. And if I try to figure out where the left of this graph is or where the right of this graph, these arrows are going to keep pushing me further left and further right. We are going to use interval notation. Okay, so my domain is going to be -infinity to +infinity, and I always put soft brackets on that. Range is bottom to top. Well, the bottom of this graph is right here. So the bottom of this graph is at -3. The top, those arrows are going to keep pushing me all the way off the top of the page, so the top is infinity. So my bottom is -3. My top is infinity. That's always a soft bracket. But if I look here at -3, I actually have a point. So that's going to be a hard bracket on the -3. Okay, so let's look at the next one. Write the vertex as an ordered pair. Well, my vertex would be right there. I can't get this new... I can't get this new stylus to hit on top of that vertex. There it is, right there. 2, -1. The axis of symmetry, therefore, is the vertical line going through the vertex. So it would be x equals the x of the vertex. The minimum value, this is a minimum. My minimum value is whatever the y is at that point. This y is -1, so my minimum value is -1. Any vertical expansion or compression, indicate any. Okay, so let's look at this. Vertical expansion or compression. So remember in my parent, I went up 1 and over 1 and hit a point. Okay, here I'm going to go up 2 and over 1 to hit that point right there. Then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8 and over 2 to hit that point. So there is definitely a vertical expansion. So in the parent, if you remember, the first move when we were looking at expansion and compression, we went up 1 and over 1, or up 4 and over 2. In this one, we actually go up 2 over 1, or up 8 over 2. So I'm going from 1 to 2, and from 2 to 4. So you can see there's an expansion that I'm multiplying here by 2. And we'll look at that more as the days come. But there's a vertical expansion by a factor of 2. Indicate any horizontal shift, left or right. So I'm actually, to get to this vertex, I take my vertex and I shifted over 2, and I went down 1. So there is a vertical shift down 1, and there's a horizontal shift of to the right 2. Domain is left and right, and those arrows are going to keep me going forever. Range is bottom, so again, the bottom of my graph is this vertex. The bottom of it would be -1. The top is going to go off the top of the page, so I'm going to be hard bracket -1, because there's a point there, to the top, which would be positive infinity. What in the world is this thing, and can we get one in Houston? That is a cupcake ATM that is outside the Lenox Mall in Atlanta, Georgia. The ATM for cupcakes works just like the ATM for money. You pick what you want, you slide your payment, and it comes out in that little drawer. How cool is that?